This is section 5.1, part 11. Let's look at our steps now that we'll use to analyze the graph of a polynomial function. We'll determine the end behavior of the graph of the function. We'll find the x and y intercepts. Of the graph of the function. We'll determine the zeros of the function and their multiplicity, and we'll use that information to determine whether the graph crosses or touches at the x-axis for each x-intercept. We'll determine the number of turning points. And we'll use this information to draw a complete graph of the function. So let's start with number 1, the end behavior. All right, that means we've got to find out what the first term would be if we expanded this out and had it in standard form. Notice that a is 1. The number here in front, the coefficient is 1. So if we multiplied this all out, we would end up with y equals, or f of x equals, I think my math lab sometimes says y equals for the end behavior, x squared times x would be x cubed times x would be x to the 4th. What does that mean? That means that this is an even function. It's positive, so it's not flipped over. That means that as x goes to positive infinity, our y will go to positive infinity. As x goes to negative infinity, our y will go to positive infinity, like a parabola that opens up. That's the two ends. There'll be some interesting things going on between, but on the two ends, that's what's going to be happening. All right, number 2 says, find the x and y intercepts. All right, the x-intercepts can be found just looking at the function. We have what? -4, -1, and 2. The y-intercept can be found by what? Letting x be 0. So let's let x be 0. And what do we get? We get 4 squared, which is 16, times 1 times -2, or -32. So the y-intercept is -32. Number 3, we will determine the zeros and what's going on at each zero, their multiplicity. And then at the x-axis, what's happening? Okay, so the zeros, of course, are the same as the x-intercepts. We have -4, we have -1, we have 2. The multiplicity of -4 is 2. That's even, so it touches. -1, multiplicity is 1, so it crosses. At 2, the multiplicity is 1, so it crosses. Notice that sum is 4, and we said that n was going to be 4. The end behavior is x to the 4th. So that was number 3. Number 4, turning points. The max turning points is n minus 1. We said n is 4, so 3 is the maximum number of turning points. And we're going to be thinking about that end behavior as we graph. So let's get our x-intercepts, -4, -1, and 2. We know that it behaves like a parabola that opens up, so on the ends, we'll be doing this. So we know we come down to -4. What happens at -4? We said we're going to touch and go back up. However high, it doesn't matter. Then we come back down at -1. We're going to cross. Our y-intercept was way down there at -32. We can't really do that, so I'll just kind of pretend. And then we come back up here to 2. And what happens at 2? We also cross there, which makes sense because we said the ends are going to be pointing up like that. So we have a little sketch we did based on our analysis of our polynomial function. We'll continue in our next video.